Welcome to Module 2. In Module 1, you learned what the Agent Accelerator is and where Build Studio fits in the BISTEC platform stack. This module is where the actual work starts. We are going to walk through the design phase, all 7 steps, and by the end you will know exactly what to do from the moment you open Build Studio to the moment you have a validated, committed DSL ready for generation. The outcome of this phase is a single YAML file, the domain-specific language file for your agent. Everything the generation phase needs, everything the engineering team needs, and everything the Copilot Studio deployment needs lives in that file. Get the design phase right, and Module 3 becomes almost mechanical. Step 1 is where the session begins. Breath. The wizard does 2 things immediately. It checks whether you have any in-progress agent designs already open, and if so, it offers to resume view or start fresh. This continuation detection is important. You will not lose work if you close a session mid-design. For a new agent, you provide a kebab case name. That name becomes the DSL file name prefix. Its support agent becomes its support agent a DSL YAML. Use lowercase, use hyphens, be descriptive but concise. Then come 3 seed questions. What does this agent do? Who uses it? What is the primary deployment platform? These sound simple, but they are not trivial. Your answers flow into every downstream step. A vague answer here. It helps IT people. Produces vague capability recommendations in step 3. A specific answer. It handles incident creation, ticket lookup, and password resets for BISTEC employees via Teams. Produces a much sharper result. Take 30 seconds to think before you type. The outputs are 2 files. The DSL, initialized with front matter and status, in progress, and requirements ND, which captures your seed answers in a human-readable form you can reference later. Before we move to step 2, it is worth spending a moment on the DSL front matter, the metadata section at the top of every DSL file. This is the machine-readable control structure that makes the wizard resumable. The status field tracks where you are in the design lifecycle. Right now it reads in progress. After step 7 approval, it becomes design complete. The generation phase checks this field before it starts. It will not proceed unless the design is complete. Current step and steps completed together give the wizard its resumability. If you close your session after step 4, come back the next day and reopen the DSL. The wizard reads these 2 fields and picks up at step 5. You do not rerun anything you have already done. Initial context stores your answers to the 3 seed questions from step 1, purpose, users, and platform. Every downstream step reads this context to stay coherent with your original intent. This is why specificity in step 1 matters so much. This is the data that gets passed forward. One more thing. This front matter is parsed by the generation phase, not just by the wizard. If you manually edit the YAML and break the front matter structure, the generation will fail. Treat the front matter as infrastructure, not a comment block. Step 2 is where you give your agent a personality and a professional profile. This is the fun step, but it has real downstream impact. The display name is what users see in the Teams or Copilot Studio chat interface. Make it human-friendly. AT support assistant, rather than its support agent. The description is a 1 to 2 sentence summary that also appears in discovery surfaces and admin portals. The persona field controls tone of voice. Formal and professional works for finance or legal agents. Friendly and conversational works for employee-facing service agents. Direct and efficient works for internal tooling where users are technical. Choose based on who will actually interact with this agent every day. The expertise areas are the most technically consequential part of this step. You provide 3 to 6 specific domains. Things like incident management, ticket escalation, knowledge-based search, password reset. These are not just labels. The wizard passes them to Claude in step 3 to seed the capability research. Vague expertise areas produce vague capability recommendations. If you write IT support as your only expertise area, Claude has to guess. If you write incident creation via ServiceNow, password reset via Active Directory, knowledge-based search via SharePoint, Claude knows exactly what integration surface to research. For Copilot Studio deployments, you also select which Entra ID fields auto-populate. This means the agent can greet users by name, understand their manager chain for escalation, and pre-fill their email in forms, without the user typing anything. Step 3 is where Build Studio earns its name. This is the step most developers are surprised by the first time they run it. Instead of you manually listing every tool, connector, and API your agent needs, Claude does the research for you. It takes your agent identity from step 2, reads the 3 MCP tools available to it, Microsoft Docs search for official Microsoft platform documentation, Context 7 for framework-specific integration patterns, and Web Search for the latest connector and API options, and proposes a complete, relevant toolset for your use case. The output is a proposed capability set. You review it, accept what makes sense, refine anything that is close but not quite right, and remove anything that does not apply. You are the decision maker. Claude is the researcher. That division is intentional. It means you understand every capability that ends up in your DSL. Build Studio also reads accumulated memories from past agent designs in your environment. Each agent you or your colleagues have designed teaches the system something about your integration surface. New agents benefit from that accumulated knowledge. The reason this step exists is practical. Teams that skip it and manually list tools consistently produce incomplete capability sets. They miss platform-native options that would have simplified deployment, and they miss engineering dependencies that block the build team later. Do not skip step 3. This slide covers the most important classification decision in the entire design phase. Get this right, and everything downstream goes smoothly. Get it wrong, and you create silent deployment failures that are genuinely difficult to debug. Here is the distinction. Platform-native capabilities are things the Power Platform or Copilot Studio can deploy as part of the solution ZIP, Power Automate Flows, AI Actions, Knowledge Sources, Adaptive Cards. No external team involvement. No waiting on a build cycle. You deploy the solution, these capabilities are live. Engineering dependencies are things that cannot be packaged in the solution's IP because they require custom code, a running service, or an integration that the platform does not natively support. Custom MCP servers, custom API wrappers, third-party integrations without Power Platform connectors, proprietary data sources. These require a separate engineering effort before the agent can use them. Why does the distinction matter? Because if you mark an engineering dependency as platform native, the solution's IP deploys without errors. There are no warnings. The agent just silently fails to do the thing that dependency was supposed to enable. You find out in UAT or production that a feature does not work, and you trace it back to a misclassification made weeks earlier in the design phase. The wizard forces you to make this decision explicitly for every capability that comes out of step 3. You cannot leave a capability unclassified. This is by design. Step 4 defines how your agent handles conversations, the control logic. There are 4 orchestration types. Generative orchestration is the recommended choice for Copilot Studio. The language model decides dynamically what to do next based on the conversation context. It handles variation in user phrasing naturally and adapts, without you having to write explicit branches. This is the right default for most enterprise agents. Topic-based orchestration is the traditional decision tree model. You define specific topics, and the agent routes users through them. It is predictable and auditable, but brittle. Any phrasing variation in the tree does not account for breaks the flow. Rule-based orchestration is strict deterministic logic, appropriate for compliance-critical paths where every step must be exact and traceable. Use it sparingly. Hybrid mixes types as needed. A common pattern is generative orchestration for general discovery and conversation, combined with rule-based flows for specific approval or compliance steps. Beyond orchestration type, Step 4 also captures the conversation flow, the main user journey from greeting through intent detection, action, and resolution or escalation. It captures your deflection strategy. What happens when a user asks something out of scope? Do you route to the knowledge base, transfer to a human agent, or politely decline? And it captures output format preferences. Adaptive cards for structured data like ticket statuses, plain text for simple answers. Step 5 formalizes every capability you classified as an engineering dependency in Step 3. This is where you turn a classification into a buildable spec. For each engineering dependency, you document 4 things: what the integration is, the API contract it needs, the data it exposes or consumes, and who owns building and maintaining it. The spec does not need to be complete at this point. A clear name, integration type, and owner is enough to unblock the engineering team. Why does the spec matter at design time? Because these specs feed directly into BIMAD PRD generation in the generation phase. When Module 3 runs the generation step, it reads your engineering dependency specs and produces product requirement documents for the build team automatically. The better your specs here, the better the PRDs that come out. Think of Step 5 as writing a shopping list for the backend team. You are not designing the implementation. That is the engineering team's job. You are communicating clearly what your agent needs to be able to do, what integration surface it expects, and who is responsible for delivering it. For the IT support agent, the ServiceNow integration is the engineering dependency, a custom MCP server, using the ServiceNow REST v2 API, owned by the platform engineering team. That is enough for them to start. Step 6 is where you confirm and capture platform configuration. Most of the time you already know what your primary platform is. You set it in Step 1. Step 6 gives you the opportunity to formalize it and add the specifics that the generation phase will need. Confirm the primary platform. For most BISTEC enterprise agents, this is Copilot Studio. If you are running a proof of concept comparison, you can also nominate secondary platforms, AWS Bedrock or Vertex AI. The generation phase can produce parallel packages for POC evaluation if you select these. Platform-specific hints are the operationally important part of this step. You capture the environment URL, tenant ID, any connector preferences, compliance framework requirements, and data residency constraints. For Copilot Studio, the environment URL is the Dynamics 365 CRM URL for your tenant. For compliance-sensitive deployments, you note the relevant standard ISO 27001 SOCCU 2, whatever applies. These hints live in workflow MD front matter. You edit them once in Step 6. In the generation phase, they propagate automatically to every generated artifact. The solution's IP, the PRDs, the governance documentation. You do not have to manually configure each artifact separately. Step 7 is the design gate. This is the boundary between the design phase and the generation phase, and it is deliberately a hard stop. The wizard presents the complete DSL in a structured preview, section by section. field by field. It runs automated checks. Are all required sections present? Does every capability have a classification? Does every engineering dependency have a name, type, and owner? If any check fails, the wizard tells you which section is incomplete and returns you to the relevant step. If all checks pass, you read through the DSL yourself. This is not a formality. This is your last chance to verify that what is in the YAML matches what you intended to build. Check the orchestration type. Check the expertise areas. Check that every capability you expected is present and correctly classified. Check the engineering dependency owners. When you are satisfied, you type C to continue. That single keystroke sets status. Design complete and locks the design. The DSL is committed to Git at this point. It is now the permanent, auditable design record for this agent. You cannot easily revise the DSL after pressing C without restarting the design session. That constraint is intentional. It enforces deliberate design. The cost of pressing C too quickly is a generation phase that produces artifacts based on a design you did not actually intend. Take your time here. The automated checks catch structural problems. The manual review catches intent mismatches. Both matter. Let's look at what a design-complete DSL actually contains. Breadth. This is the IT support agent DSL after Step 7 approval. The top-level structure has 6 sections: identity, capabilities, workflows, platform hints, and dependencies, plus the front matter at the top with status. Design complete. Notice the capabilities section. Each capability has a name and a type. ServiceNow integration is typed as engineering dependency. Knowledge source is typed as platform native. Every capability must have one of these 2 values, no third option, no blanks. The workflows section has 2 required fields: orchestration type, generative in this case, and deflection strategy, knowledge base. These are the minimum required fields. You can add more detail, but these 2 must be present. The dependencies section lists only engineering dependencies, with their owner field populated. The platform native capabilities do not appear here. They are fully described in the capabilities section and will be handled automatically by generation phase. The important invariants are: every capability is classified, every engineering dependency has an owner, and the orchestration type is set. If any of these are missing, the Step 7 automated checks will catch it before you can press C. This YAML is now machine-readable by the generation phase. Malformed YAML, missing required keys, or typos in classification values will cause generation failures. Treat it as code, not a document. We have covered all 7 steps. Before the walkthrough, let's consolidate the most important tips and the pitfalls most likely to cause you problems. On the tips side, be specific in your expertise areas. AT support is not an expertise area. Incident management via ServiceNow is. The specificity directly determines the quality of Step 3's research output. Let Claude do the research in Step 3. Teams that skip it and manually list tools consistently produce incomplete capability sets. And use requirements M&D as your reference before modifying an existing DSL. It captures the original intent that the YAML alone does not always convey. On the pitfalls side, the most serious one is misclassifying dependencies. If you mark an engineering dependency as platform native, the solution's IP deploys cleanly, but the feature silently does not work. You will not see an error at deploy time. This is the hardest class of design phase bug to diagnose, and it is entirely preventable by careful classification. Second pitfall, skipping the Step 7 review. Pressing C without reading the full DSL leads to generation surprises, wrong orchestration type, missing capabilities, engineering dependencies with no owner. The generation artifacts will be technically valid, but functionally wrong. Third pitfall: loading two-step files simultaneously. Never open two-step files at the same time. Always complete and close one step before opening the next. Concurrent step files corrupt the DSL state, and the wizard cannot recover from it automatically. We have been building toward this walkthrough. Let's confirm what the IT support agent design produced across all 7 steps. Identity: display name IT support assistant, friendly and professional persona, 4 expertise areas, incident management, knowledge base search, password reset, and ticket escalation. Specific enough to drive good capability research. Capabilities: 3 total. The ServiceNow integration is classified as an engineering dependency and will require a custom MCP server from the platform engineering team. The knowledge source is platform native and will be packaged in the solution ZIP. The ticket lookup AI action is also platform native and will be in the solution ZIP. Workflow: generative orchestration for the main conversation. Deflection strategy is to route unknown queries to the knowledge base before escalating to a human agent, so users always get some response before being handed off. Result: a complete, validated DSL with status. Design complete, committed to Git. The platform engineering team has a clear spec for the ServiceNow MCP server. The generation phase in Module 3 can start immediately from this DSL. This is what a clean designed phase output looks like. 3 capabilities, clearly classified, 1 engineering dependency with an owner, generative orchestration. It is not complicated, it is specific and complete. That is the design phase complete. You now have the knowledge to execute all 7 steps independently for any agent. Module 3 covers steps 8 through 14. The generation phase. We take the validated DSL we have just built and use it to generate real, deployable artifacts. For Copilot Studio, that means a solution ZIP ready for PAC CLI import, no manual configuration in the Studio UI. For the engineering team, that means product requirement documents generated automatically from the engineering dependency specs you wrote in Step 5. For governance, that means compliance documentation generated from the platform hints you set in Step 6. The design phase is where you make decisions. The generation phase is where those decisions become deployable software. The quality of what comes out of Module 3 is directly determined by the quality of what you put into the design phase today. Before Module 3, complete the 2 exercises in your session materials. Exercise 1 asks you to run steps 1 through 3 for a leave request assistant, init, identity, and capabilities. Exercise 2 is a classification exercise. For capabilities, you decide platform native or engineering dependency. Both exercises take under 20 minutes and will solidify the most important concepts from this session. See you in Module 3.